with the blessings of the Almighty, it gives me immense pleasure to extend a warm welcome to each and every one of you to the session 9 of the 5th day of the ACT ATAL sponsored faculty development program on smart energy systems for climate resilient and sustainable development, organized by Sri Chandrasekharendra Saraswati Vishwa Mahavidyalaya. We are truly honored today to have with us our distinguished resource person, Sri K.R. Sridhar, Assistant Executive Engineer, TNPDCL, Ranipet, who has graciously accepted our invitation to share his expertise with us. Sir, we are delighted to welcome you and we look forward to your insightful deliberation, which I am sure will enrich our learning experience. I also take this opportunity to warmly welcome all the participants, faculty members, scholars, and colleagues who have joined this session with great enthusiasm. Your active participation and interaction will make this program more meaningful and impactful. Now, I request my co-coordinator, Dr. Lashmibai ma'am, to introduce Engineer Sridhar sir to our participants.
Thank you, ma'am.
Good evening, everyone present here. It's given me immense pleasure to welcome Mr. K. R. Sridhar, who is currently serving as an Assistant Executive Engineer in the Operation and Maintenance Urban Division, Ranipet, under Tangetco TNPDCL. Mr. Sridhar brings with him a wealth of knowledge and rich experience, having dedicated 27 years of service to the TNEB, that is Tamil Nadu Electricity Board, since he joined in February 1998. Over these years, he has made significant contributions to the power sector through his technical expertise and commitment. Academically, Mr. Sridhar completed his undergraduate degree in electrical engineering from Anna University, CEG, Guindy in 2004, and has recently pursued higher studies, completing his postgraduate degree in power system from SCSVMV in 2025. His constant pursuit of learning reflects his dedication to both personal and professional growth. One of the notable highlights of his career is his nine years of specialized work experience in the power transformer repair bay at TNEB, where he played a crucial role in identifying and rectifying transformer faults at an early stage. His efforts have not only safeguarded valuable TNEB equipment but also ensured uninterrupted service to customers, showcasing his deep sense of responsibility and technical acumen. We are truly honored to have such a seasoned professional among us today. His journey of dedication, technical excellence, and service to society is truly inspiring. Please join me in extending a warm welcome to Mr. K.R. Sridhar. Welcome, sir. The stage is yours.
Thank you, ma'am. Thank you for your wishes. Good evening to everybody, sir. I'm Sridhar, working as Assistant Executive in Tamil Nadu Electricity Board in Urban Ronipet Division. I'm joined in TNEB during the year February 1998. And from there, I'm traveling in TNEB up to this stage. I have joined in TNEB as a technical assistant and elevated as assistant engineer. Now I am pursuing assistant executive engineer as TNEB and serving to the Ranipet urban area consumers. Today, I would like to express my context in energy transition. Energy transition impact on electricity grid and management, and its tariff implications. You would all know that electricity is vast one, and it is connected with crores of consumers. In Tamil Nadu, we have 3 crores of consumers, and we have maintained a power maximum of 22,000 megawatt during last summer. Today, energy transition means, first we should know grid. What is meant by grid? Grid is the largest network connected with number of equipments like transformers, generators, transmission lines, and it delivers electricity from generating station to and fed the supply to consumer in. From there to end user, we face a lot of problems, and we involve in getting the consumers with quality of service, quality of supply. For that, we are all working in this department.
Sorry, excuse me, sir.
Tell me.
Can you put in presentation mode, sir?
Yes, yes, madam.
That is under the file, one icon is there from beginning. Can you
Okay.
please click it?
Yes, madam. Energy transition, impact on electricity grid management and electricity tariff.
Sir, left side, one icon is there under the file. One icon is there, no, from beginning. So you just click it on, sir. It will give
Full
you the
screen.
full presentation mode.
Okay. It's okay, ma'am?
It no, sir, it's not coming. Left side, top, left side top.
On
Left
the
side.
slide, மேல sir, மேல மெனுல மேல yes sir.
Yes, yes, yes.
பக்கத்துல கீழ.
Next,
From
left,
current
left,
slide. Okay.
left, sir, left.
Yes sir, that's correct.
First one. From beginning.
From current slide.
Okay.
Okay, ma'am. It's okay, ma'am? Hello?
It's not. No, sir, it's not coming.
Slide,
Click it
slide,
Maybe,
slide.
sir, you need to stop sharing and reshare your complete full screen, sir, desktop full. Then you will get it. Currently, you're just sharing the only presentation.
Dinesh? Dinesh?
Sir, can you able to click that from current slide or from beginning?
Yes, madam.
Madam, the problem is that it is slideshow is going in another presentation window. The sharing is only the PPT, not the slideshow. That is the reason it's not coming up for me, for us.
Okay, okay,
Full screen has to be shared. Entire desktop has to be shared.
okay.
So is it okay, sir?
No, sir.
No, sir. Sir, you can stop sharing and again reshare with full screen, sir. I mean, complete desktop.
1 minute, sir.
Entire screen.
So 1 minute, sir. Slide share over. Being a full. Sharing.
First, you stop the sharing and again you enter into sharing with the entire screen. In the bottom, there is a share screen, no?
Right click on. Okay. Okay. Well,
I just disabled sharing. Can you retry sharing the entire screen, sir? Yeah. Again,
yes,
bottom you can see the share option. Click on that. Top you can see entire screen. No, again only the PPT is there, sir. Same திருப்பி issue வருது.
நீங்க வெளிய வந்துட்டு click join.
சார் நாங்க ஷேர் பண்ணவா?
மேடம் மேடம்
நாங்க ஷேர் பண்ணவா?
1 minute மேடம். ஷேர் வேணாங்க. ஸ்ட்ரைட்டாவே மேடம் ஓகேவா மேடம் இது?
இப்போ ஸ்கிரீன்ல இல்ல சார்.
ஃபுல் ஸ்கிரீன் வரீங்களா மேடம்?
ஆமாங்க சார். ஸ்லைட் ஷோல போங்க.
ஓகே மேடம்.
ஃபுல் ஸ்கிரீன் மோட்.
எனக்கு ஃபுல் ஸ்கிரீன்ல தான் இருக்கு மேடம்.
Sir, otherwise you in the bottom, no, one that tumbler symbol like that, no, you just click it in the bottom right side corner. Is it visible? Right side corner la irukku parunga. ஒரு சிம்பல் இருக்கு பாருங்க, டம்ளர் சிம்பல் மாதிரி இருப்பாங்க. அதை கிளிக் பண்ணுங்க.
பண்ணிட்டேன் மேடம்.
சார்
சொல்லுங்க மேடம். ஷேரிங் ஸ்டாப் பண்ணிட்டேன்.
Otherwise, Anisha ma'am, whether you are having the PPT, can you share for him?
சார் ஒன்றும் இல்லை, நீங்கள் வந்து நான் சாட் விண்டோவில் ஒரு ஸ்க்ரீன்ஷாட் அனுப்புனேன் ஃபுல் விண்டோ எப்படி ஷேர் பண்ணதுன்னு சொல்லிட்டு. நீங்கள் கீழே அந்த ஷேர் ஆப்ஷன் கிளிக் பண்ணீங்கன்னா க்ரீன் பட்டனு உங்களுக்கு ஒரு பாப்அப் வரும். மேலே வந்து அப்ளிகேஷன் என்டையர் ஸ்க்ரீன் இருக்கும், அதுக்கு அடுத்த ஆப்ஷன் வந்து அப்ளிகேஷன் விண்டோஸ் இருக்கும். நீங்கள் என்டையர் ஸ்க்ரீனை ஷேர் பண்ணுங்கள் சார், அது போதும். Now it will work, sir. Yeah, we can see. Thank you, sir.
Yes, sir. Yes, sir. You can continue, sir.
We are sorry for this technical issue to all the participants. Now let us start the session. Sir, please unmute பண்ணுங்க. Yes, sir.
Okay, ma'am.
Yes, sir.
Yes. Oh, sorry, ma'am. Sorry for the interruption. We are study about what is electrical grid. Electrical grid is a network of synchronized power providers and customers that are connected by transmission and distribution lines and operated by one or more control centers. So as I said earlier, electrical grid is connected with the number of networks and equipments like transformers, generators, transmission lines, and finally with the consumers. As of generation is considered, now we can see the view of energy grid. We have generating stations, transmission lines, substations with step-down transformers, step-up transformers, and consumers connected across the different type of loads. The generating station is generally transfer the electrical energy either through EHV AC lines or DC lines. The voltage rating of EHV lines either 800 or 765 kilowatts, 400 kilowatts AC, 200 kilowatts, 220 kilowatts, and 130 kilovolts. Commonly used HVDC lines are 500 kilowatts. So we may use either EHV lines, AC or HVDC lines. Normally we are used for transmission lines. Customers, especially the sub-transmission consumers connected with 33 kV lines, primary customers at 11 kV lines. The secondary customers, that's our end users, like our residential people are using 400 volts or 230 volts. The topic is energy transition. Why energy transition means shifting of energy generated from fossil fuels to renewable energy has a big impact on electrical grid management. Electricity tariffs also impact on this energy transitions. The energy impact transition causes the impact on energy management also. Just we see the impact on the energy management. The electricity grid must stay balanced in real time. That is, supply is equal to demand. That is a major problem in our electrical grid. We have faced a lot of problems during peak hours that our generated energy is not equal to meet the demand during the peak hours. So by the time we have do lot of mechanism works like DSM, demand response programs, and other things. So we have to go for normal conventional grid to smart grid in future. The impact on another impact is higher renewable integration. Solar and wind energies are not constant at every time. It's variable one, depends upon the climatic conditions, causing fluctuations in generation. So that grid faces a lot of problems like frequency variations. So that it requires flexible grids, advanced forecasting, and real-time control. The another one is a need for energy storage. Since the solar and wind are or not or depending on the climatic conditions, and the generation of energy is not being constant at all the times. For example, if it is in the daytime, the peak is our peak is somewhat be lower than evening peak. So by the time the energy developed by or generated from the solars can be stored in batteries that can be pumped into grid during the evening peak hours. So need for batteries. Likewise, in the night times, our wind energy is much more than daytimes. So normally our usage during the night hours are very less. So the energy generated during night hours by the windmills are being again stored and can be utilized in the morning peak hours or the evening peak hours. So need for energy storage system is essential. Distribution generation, DERs. Nowadays, government has also been implementing some programs to enhance the consumer to install rooftop solar microgrids so that the peak demand arised in the grids can be managed by these microgrids or from the consumers, so that the bridge between supply and demand can be met. So it is inevitable in synchronizing the distributed powers into the normal grid. Digitalization and smart grids. Smart meters, sensors, and AI-based demand forecasting became essential. Grid strengthening. More transmission lines are needed to move renewable energy from remote areas to cities. So grid strengthening is also very important because a lot of renewable energy integration of power sources are being fed to the normal grid. We need to strengthening our transmission grid also to meet the peak demands. Like this, transition of energy means shift from one dominant source of system energy to another energy, usually to achieve sustainability of the grid, efficiency, and environmental benefits. Energy transition mainly refers to moving away from fossil fuels like coal, oil, natural gas towards renewable energy sources like solar, wind, hydro, biomass, and geothermal energy, along with energy efficiency improvements, smart grids, energy storage, and electrification of transport and industries. Why we need for smart grid means to reduce the greenhouse gas emissions to combat climatic change. Second thing, increase energy security by diversifying the energy sources. Third one is promote economic growth through new technologies and green jobs. For example, replacing coal power plants with solar farms or wind turbines. Replacing coal power plants with solar farms or wind turbines. Switching from petrol or diesel vehicles to electric vehicles. Developing smart grids to handle renewable energy integration. Now we can see the smart grid picture. It is connected with our data center, solar farms, different kinds of generations like hydro, smart houses combined with rooftop solars, electric vehicles, and other things with it. It's a small layout. Electrical grid components. electrical grid components naturally having generation, transmission, distribution, and consumers. We know different types of generations: thermal, hydro, nuclear, then renewable energy sources. Likewise, transmission lines are either HVAC lines or HVDC lines. Distribution becomes whether AC lines, alternative circuits, or DC circuits. Consumers are industrial consumers, normally industrial consumers, commercial consumers, and domestic consumers. We can see the vertical structure: generation, transmission, distribution, and consumers. In the above vertical structure, the consumers, as we all know, they are industrial types, commercial types, and residential domestic types. The electrical energy grid structure historically vertical in nature. That is, the energy is being produced at the generation station, then being transmitted through transmission lines, distribution lines, and reaches to the consumers. But with the new technology and the mega penetration of renewable energy nowadays at low voltage levels, may allow the energy to flow not necessarily from top to bottom, but it could be from bottom to top also. So the renewable energy consumers are now called as prosumers because they consume the electricity from grid, as well as they supply energy to the grid when it needs. So that they are called as prosumers. The vertical structure currently may have two different forms. That is, energy flowing from generation to consumers, and the energy may flow from consumer to generation through transmission and distribution lines. Before that, in Indian electricity power scenario, we can see that in the earlier we have 5 grids. In each grid, some states are being interconnected for transforming their excess energies or import some excess energy from other states also. So first, we have 5 regional grids, that is northern grid, eastern grid, western grid, and northeastern grid, and southern grid. During the year 2006 August, the north and east grids were interconnected by 4 regional grids. That is, northern, eastern, western, and northeastern grids are synchronized for forming a central grid operating at one frequency. During the year 2013, to manage and interconnect all the 5 regions into one grid, that is called one nation, one grid, one frequency. The southern regional grid was interconnected to the central grid in synchronous mode with commissioning of 765 Raichur Solapur transmission line, thereby achieving one grid, one nation in India. That is, we have now only one frequency throughout India. The above grids are controlled by some authorities formed by central government, that is Ministry of Power, MOP. The MOP will deals with planning, policy, formulation, processing, and implementation of projects, enactment of legislation in regard to power generation, transmission, and distribution. Ministry of Power is the supreme authority to plan generation needs by the country, and which form some policies for giving supply to the consumers of different types. They are making some policy formulations. Processing and implementation of projects are all carried out by the Ministry of Power, by the central government. PGCL, Power Grid Corporation, India Limited is responsible for national and regional power transmission planning. This is the only limited is responsible for national grid forming for transmitting the power according to our needs or demand, which are all controlled by Ministry of Power. The next one is Central Electricity Authority. It is also comes under the control of MOP. Advises on matters related to national electricity policy. Policies are being formed and approved by the Central Electricity Authority, and formulation of short-term and prospective plans for development of the power system. The second thing is CRC and SCRC. State Electricity Regulatory Commission or Central Electricity Regulatory Commission are the regulatory body of the State Electricity Board. They regulate the tariff. Mainly SCRCs are regulate the tariffs which are in inclination with the CRC policies, and formulates policies regarding to subsidies and formation of and promotion of efficient and environmental policies at central and state level respectively. The last one is under the control of CTU and STU, Central Transmission Utility and State Transmission Utility. They are developing efficient and coordinated economical system of interstate and intrastate transmission lines. The interstate and intrastate transmission lines are controlled by the state and central transmission utilities. Just key figure for our country. Our population of India 1.4 billions, total area 3.287 million square meter. Energy mix, we have different types of energy generations from oil, coal, gas, nuclear. Electricity consumption of our India is during the year 2024-25 is 1,622 terawatt hour, which is half of the power as like China. We are producing so much of power. So we plan that accordingly our transmission lines to carry the such a power to pump for throughout the nation. Generally, our generating capacity of 476 gigawatt. Overall network losses is 16 to 17%. Now, if you look at the key figures of our country in 2024-25, that we have seen that the very challenging component is our overall network losses. It is reasonably high, which is expected to be far lower than what is being mentioned. Currently, it is 16 to 17. So the transmission losses are too high, which may be brought into single digit. The above Ministry of Power is introducing so many programs to various electricity state utilities for reducing the transmission losses from 16% to single digit. We are also doing some kind of projects like HVDC, agriculture feeder segregations. We are doing it. So we need to try our level best to make sure energy does not move longer distance. So long distance travel of power consumes or produce losses to the utility. That loss can be dropped by few percentages in near future by introducing the government programs into state electricity boards. And certainly the smart grid will help us that the distribution losses will drop further. The Indian power scenario The power produced from thermal power stations is using coal is 215 gigawatt. The power from renewable energy sources are 179 gigawatt. Hydro is 48 gigawatt. Nuclear is 9. Diesel is 0.83 gigawatt. Gas 24. That's we can see that the renewable energy from 2016 to 2025 is abruptly increased. That is, during the 2016, it may around 70 to 75 gigawatt. Within 6 to 7 years, it has been tremendously increased to 179 gigawatt. One thing it is very keen to mention, the renewable energy contribution in India is close to 197 gigawatt, and that is close to 38% of the total energy mix. And it is good idea, and we will keep on increasing those renewable contribution in future to achieve low carbon footprints in this country and contribute to the global challenge in achieving green energy in future. This is the slide. Installed capacity in gigawatt past 10 years. The figure shows up to 2022. You can see this. The installation capacity of the solar and wind are tremendously installed and reaches to 10 gigawatt by renewable energy sources during the year 2022, and now it is become 179 gigawatt. In another 4 to 5 years from now, we are going to add as IS renewable energy sources to 250 gigawatt. Our central government plan is also planned for achieving this very quickly, so that PM Suryagar programs are introduced by Ministry of Power, and they are insisting the consumers to erect solar rooftops and they are planned 40 gigawatt from the consumers itself, from the domestic consumers only. We are trying to achieve this. Next 4 to 5 years, we may achieve only from the rooftops throughout India. We may get 40 gigawatt of power from solar rooftops. Now you see that so far we see the grid conditions. The factors which are affecting the performance of the existing grids are increasing demand of electricity. There is increasing demand of electricity is day by day increasing because of our loads are being increased even from domestic also, even from domestic sector also. That's the air conditioning loads, heating loads are all being tremendously increasing last 4 5 years. So we cannot able to match with the demand to the generations, so that we may face some grid problems during peak hours. Supply shortfalls of electricity. The second thing is supply shortfalls of electricity. Then we have a lot of higher side of transmission losses that has to be bring down to single digit, so that also our existing grid getting disturbed during peak hours. Then peak demand management. Then integration of renewable generation systems. The integration of renewable energy generation to the normal grid have faced some problems. Because of that, in renewable energies, we may not have steady power generation from, or we may not expect constant power from our renewable sources, so that our grid can face frequency problems as well as voltage problems. That is given in the slide. The supply and demand are not matched. The energy production is slightly less compared to the energy expected during peak hours. The need for reducing loss is one of the major factors. As we said, we are at very close to 17% of distribution losses that need to be reduced. Today, especially during peak hours, we experience peak shortage of close to 4 to 5%. With our generation, we may face a deficit of 4 to 5% during our peak hours, which may produce some problems to the grid. The grid frequency has been down and voltages has been down, so that we need some programs to help the grid to bring down to normal operations, and stability of the grid can be achieved. One thing I would like to highlight here, when you like to reduce the peak energy gap by putting energy sources, it is very difficult to go for the huge nuclear or hydropower or thermal power plants. That is, all of a sudden we cannot be direct thermal plant or nuclear plant to match the generation with the demand is all of a sudden it is not possible. It will take 6 to 10 years time. So very quickly we cannot meet our peak shortages. So the only one way at this point is that putting renewable energy sources into the grid as maximum possible as maximum in our country. That lead to achieve excess generation, installed capacity, and may reduce the gap between the peak energy requirement and the energy available at the time period. The integration of renewable energy generation system also do pose challenges. The solution to global warming, we all have to contribute effective use of electric vehicles. Currently, we are doing that. They are widely being manufactured, and the charging and discharging pattern are never being technical as of now, and they need to be organized to manage the grid conditions, so that the charging can be done during off-peak periods, and the charging is not possible, at least the charging can be respected. This means the electric vehicles are normally being preferred by the people as of now, and government also implementing some rules to go for green energy vehicles, so that people are going there to buy there. Therefore, the charging may be done at the night times, may reduce the peak demand of the grid, so that we are also being, it may also reflect in the tariff implications also. Factors affecting the performance of the existing grid also by the following factors: aging assets and lack of circuit capacity. That is, power network installed beyond our lifetime, they have to be need at a stretch is not possible, and it involves many financial crises, so that our grid cannot be enhanced to our need. The capital cost for replacement will also be very high. Security of supply. Need of reliable electric supply as more and more critical loads are connected. Need of reliable electric supply as more and more. Since the critical loads are connected, we need more electricity of supply. And another one is thermal constraint. Transmission distribution lines at its maximum limits during peak hours. Reduction, so that the reduction in the life of the equipment that also causes increasing incidence of faults, so that our grid can getting disturbed and we cannot able to supply to the consumers with reliable and quality supply. That is thermal constraints, operational constraints are the key factors for the grid disturbance. The thermal constraints, transmission and distribution lines are at its limit. Most of the lines are congested or overloaded. Reduction in the life of the equipment, so that it causes reduction of the life of the equipment, increasing the incidence of faults. So since the life of the equipment is decreasing and may have a chance to incidence of faults may experience more and more on the corridors of the grid. Operational constraints like voltage and frequency limits, uncertainty of renewable sources. As we said earlier, the solar and winds cannot be expected as we plan or as we schedule, that we cannot be able to achieve that due to climatic conditions. During that conditions, what we have to do, some operational constraints have to be taken by the energy management system. In 2040, we have to add actually huge amount of energy sources across different energy mix, starting from thermal, nuclear, hydro, and renewable, from the all segments. The question is that, so that we currently operating energy grid, which is not smart enough, or what we understand by smart grid, or what makes the grid to smart. So we are moving towards to overcome the problems faced in the conventional grid. To overcome that, we should go for, or we are needing go for smart grids. The driving forces for smart grid, the distribution network power losses are high. As we said earlier, it's 15 to 17%. The distribution network losses has to be reduced by introducing renewable energy sources or forming smart grid. Then distribution equipment failure due to overloading. Our conventional grids are being overloaded. The third one is efficient reactive power management is required to improve the power factor. Efficient reactive power management is required to improve the power factors. Poor voltage profile of the system, the number of breakdowns and the frequent interruptions on distribution feeders are high, are the driving factors for smart grid. Yes. To enable decentralized power generation. Nowadays, since the consumers are become the prosumers, the tariff implications are also being very important for them. To enable the decentralized power generation, so homes can be both an energy client and supplier. The lack of efficient tools for operational planning to minimize the load shedding. Flexibility of power consumption at client side to allow supplier selection. Need for increasing reliability, efficiency, and safety of the power grid. So here arises a need to make the power system a modern one and smart one. So we go for smart grid. What makes the grid smart? The digital technology that allows two-way communication between the utility and its consumers, and the sensing along the transmission lines is what makes the grid smart. This is smart grid. Smart grid is that introducing digital technologies. The technologies will allow the communication for two-way communication. That is from grid to utility and utility to grid, consumers to utility. Like the communication can be increased, so that we can go for or we can ascertain the real-time demands. Accordingly, we can able to plan the generations or other our renewable sources come into our grid. So that is possible with the help of smart grid. Customers will no longer have to wait monthly statement. The consumers, as a consumer point of view, consumers no longer have to wait for the monthly statement to know how much electricity they use. With a smarter grid, he can have clear and timely picture of it. Smart meters, by use of smart meters. And consumers also plan for which which kind of source we can have for their utility. Consumers may choose their generators. So that kind of flexibility is available in the smart grid rather than conventional grid. It's a slide showing the smart grid. It contains operators, marketers, and service providers, and various kinds of generations and consumers. You can see that the dotted lines in blue are the communication lines, and in orange we can see that power lines, generation, transmissions, and distributions to the consumers. Consumers also it's supplied to the grid also with the help of smart grid that can be controlled by the energy management system. And nowadays, for meet out the demands, some private marketers are there. From there also consumers can purchase the supply during demand or any critical loads they need or demand they need. The National Institute of Standard and Technology provides the pictorial view of the smart grid, conceptually how it works. We can see that. My operating center, we have do energy market and we have do some service providers. Now, the very interesting part that the thick lines, you could thick lines, dotted lines shown in blue color are the interconnection of bulk transmission and distribution consumption. Sorry, orange color dotted lines are used to connecting the bulk generation, transmission, distribution, and the orange lines are electrical power source which have been interfaced, and the clouds are nothing but the domains. Another European standard smart grid definition. A smart grid is an electrical electricity network that can intelligently integrate the actions of all users connected to it. That means it can act intelligently, intelligent generators and consumers, and those that both are interconnected through communication lines as well as power lines, in order to efficiently deliver a sustainable, economic, and secure electricity supplies. A smart grid employs innovative products and service together with intelligent monitoring, control, communication, and self-healing technologies. The smart grid is better facilitate the connection on operation of generators of all sizes and technologies, allow consumers to play a part in optimizing the operation of the system. Allow consumers to play. Consumers can extract the supply from the grid as well as they may supply power to the grid also. Provide consumers with great information and options for choice of supply. So consumer can have the choice for choosing the supplies. significantly reduce the environmental impact of the whole electricity supply system. Since the renewable energies are used to produce generations, the carbon prints to the nation is reduced. Also maintain or even improve the existing high levels of system reliability, quality, and security of supply. Maintain and improve existing services efficiently. Foster market integration towards European market integrated market. Duties of smart grid. More efficient transmission of electricity. The smart grid duties mainly is to handle more efficient transmission of electricity. Then quicker restoration of electricity after power disturbances. The prime of the smart grid is quicker restoration of electricity after power disturbances. Whenever the disturbances occur, it can quickly sense the fault and rectify the fault, or otherwise divert the power from some other sources. Such technology will be available in the smart grid. The smart grid also reduced operations due to smart grid, reduced operations and management cost for utilities, and ultimately lower power cost for consumers. The interruptions are low, then definitely the cost of the units will be also lower, and customers also getting energy at lower cost. The smart grid also reduced peak demand, which reduces the demand during the peak hours, which will also help lower the electricity rates. Definitely, it will reduce the electricity rates, since the renewable energy sources are useful during the peak hours and reduce the demand, so that electricity also price also being getting reduced. Increase the integration of large scale renewable energy systems. Smart grid can accommodate increased integration of large scale renewable energy systems. Large scale energies can be added to the grid. Better integration of customer owner power generation systems. As we said earlier, it will better integration of customer under the grid, including renewable energy systems. Therefore, the system will be improved, and the security of the system has been also in the existing grid. And smart grids are electromechanical, smart grids are digital one, so one-way communication, two-way communication. The centralized generation. The existing grids are centralized generation because the power stations are at one sector and can be transferred through transmission utilities for a longer distance. Whereas in case of smart grid, number of distributed generations which are being smaller in capacities and can be installed throughout the high voltage levels or low voltage levels, because every consumer is also having rooftop solar and other thing is installed, so the capacity of the distributed generation is somehow be lesser than the centralized generation. Limited sensors. The sensors are used to measure the parameters of the grid, which is being very less in the existing grid, and smart grids are being incorporated with the more sensors, so that it can sense the fault, diagnose the fault, and rectify the fault at lesser times. One is manual monitoring. Smart grid is a self-monitoring. Failures and blackouts are may happen in existing grid. In smart grid, it's adaptive and islanding. So if any problem occurs, it's island the area and minimize the breakdown areas, so that the grid reliability can be increased. Then existing grid have limited control, whereas smart grid have as we control. It's a manual restoration and it's a self-healing. That means if any problem occurs, you can divert the fault area and energize the area which is being having, which is being or which is not having any fault in that lines. So self-healing, it will divert the supply from another sources. These are all the difference between existing and smart grid. If you shows the smart grid architecture in which various kinds of energy generations like thermal energy, nuclear energy, thermal plant, electric vehicle, and hydro pumped storage systems like solar, and we have energy storage systems. The solar and wind powers are being fully exhausted during the generation time itself, so it can be stored in energy storage systems so that batteries are used in solar power system. Windmill are clubbed together and they are managed with energy management system and having supply to the distribution stations through energy management systems. This is called smart architecture, smart grid architecture, where we can see the distribution stations like power from solar energy storage devices and wind power plant all constitute a renewable energy sources. And then we can experience hydropower generation, and through underground cable they can be interconnected to some energy management system. From the energy management system, they have managed the power to consumers according to their demands and manage the grid demands. They are introducing some plans and executing some controls through management systems. Smart grid components are major main components of the smart grids are classified. One is smart grid infrastructure, smart communication, smart management, smart protection. So smart infrastructure, smart communication, smart management, and smart protection comprise together to form a smart grid components or the components. The smart grid can be further divided into smart energy system and smart information system. Smart energy system is mainly comprised with power generation, transmission, distribution, in which the smart information systems club together make the smart grid system very effective and reliable and sustainable one. The smart information system consists of smart metering sensors, phasor measurement units, and information management. Look into the smart metering, the major component. Smart meter is usually an electrical meter that records consumption in intervals of an half an hour or less than, and it sends the information at least daily back to the utility for monitoring and billing purposes. The conventional meter will be done like this, whereas automatic meter reading is the technology of automatically collecting, diagnosing consumption and status of the consumption and status of the devices, and the data from energy metering devices are transferring that data to central base for billing or troubleshooting or analyzing the conditions or status. The next one is automatic meter interface, which differs from traditional AMR meters in that it enables two-way communications. AMR, automatic meter reading system, is only collecting the data from the devices or consumption and status of the grid, which will send to central database. Whereas in the automatic meter infrastructure, it is having two-way communications with the meter. Therefore, nearly all of this information is available in real time. Since we may have given any control from utility to grid, or the data are being transferred from grid to utilities. So it's having facility of two-way communications to make the grid smarter. Smart metering is a fundamental foundational component of the smart grid, enabling two-way communications between utilities and consumers to create a more efficient, reliable, and sustainable energy system. What's the role of smart metering in the smart grid means? Smart meters are data hubs at the consumer edge of the grid. These serve as sensors and communication devices that measure electricity in real-time base. It sends the consumption data to the utility at frequent intervals, that is 15 minutes. Key functions of the smart metering are real-time monitoring, that means tracks household and grid level demand electricity dynamically. Dynamic pricing enables the time of use (TOU) and real-time pricing based on the grid loads. Demand response supports the automated load and shifting during peak hours. Outage detection and management. Smart meters able to locate outages instantly, reducing downtime. Because smart meters can send the data on both way communications. It's also having advanced activities and detect the or tampering of the anomalies present in the grids. Next one is sensors. Sensor networks are used as a monitoring and measurement unit for grid. Need of sensors in the grid. The sensors are quality of service requirements, used resource constraints, remote maintenance and configuration, high security requirements, harsh environmental conditions. Third one is spacer measurement units. The PMUs measures the electrical waves on an electrical grid to determine the healthiness of the system or grid. It's also with the GPS timing. Sensors are used to monitor, measure, communicate, and control different aspects of the power system in real time. That is, sensors are used for real-time monitoring of the grid parameters. The grid parameters are like voltage, current, frequency, power factor, load flow. This data is essential for maintaining the grid stability, balance, and efficiency. Also, sensors are used for fault detection and isolation. The phasor measurements units and intelligent electronic devices (IEDs) are used to detect faults such as short circuits, line breaks, or ground faults. The grid can automatically isolate the fault and remote power, reducing the downtime. That is called self-healing, which can be enabled through smart grid facilities. Integration of renewable energy sources. Sensors are able to variability of solar and wind generation. It can monitor and sense the variability available in the solar and wind generations. Also, bidirectional flow from distributed sources. It also senses the bidirectional flow from distributed sources to grid and storage systems, which also monitor the solar systems. Then the sensors are used for condition monitoring and predict maintenance, like equipments for equipment protections and monitoring aspects for transformers, the temperature, oil level, gas content has been monitored automatically or in the auto manner. Circuit breakers like vibration pressures, SF6 pressures are being sensed by the sensors. And it is in cables and lines to detect the load current and temperature. The sensors enables predictive maintenance, reducing unplanned outages and extending equipment life. Grid
Yes, the screen is disconnected, sir.
Okay.
Okay. Signal problem, sir.
Okay. Next.
Yes, sir. There is a technical problem with the resource person. So please just wait. Sir, is it okay now? Dear participants, tomorrow we will have
Oh,
our sessions from 2 o'clock.
okay.
We have 3 sessions tomorrow. Tomorrow
We
is the
expect
final
all
day.
your presence during the valedictory session. And we have a online test also. I request all the participants to attend tomorrow's sessions. Sir, you can start, sir. Your screen is visible.
Okay, ma'am. Okay. Oh, yes, ma'am. Thank you. The next one is smart communications. It deals with connectivity and information transmission among the system from the grid can be effectively coupled through the smart communications performance of the sensors and smart meters, so that we can use different types of communications: wireless, mesh communications, cellular communications, cognitive, satellite, wired communications, or fiber optic communications, and power line communications, or wired communications used. In TNEP, we can use power line communications as major one. Now we are changing smart protection. Protection is very essential for the grid. We have for the smart grid failure protection mechanism. Failure prediction and prevention is important. Failure identification, diagnosis, and recovery. Smart protection can be able to do that. That is the ability to compensate, ability of the component or system to perform record functions under stated conditions for a stated period of time. Smart grid also some have barriers. The following are the barriers: huge amount of investment and lack of financial resources, market uncertainty, lack of regulatory framework, low public awareness and engagement, lack of innovative technology immunity, integration of the grid, large scale renewable generation. Peak demands arise in the grid. They are and demand response programs. The demand management operations of electricity consumption pattern to produce the desired changes in the load sheds of power distribution systems. Focuses on utilizing the saving technologies monetary incentives and government policies to enlarging the generation capacity or reinforcing the transmission and distribution network. The objective of the demand side management could be maximize the use of renewable energy sources, maximizing the economic benefit, minimize the power imported from main different types of DSM. DSM reduced to this horizontal line. The peak can be reduced by the peak. That's by energy conservation or using implication or control. The demand can be applied or generating capacity. Means in this the peak and the non-critical loads during the off-peak period. Filling slightly different. That we can run the non-critical equipment is conservation. To implement conservations like consumers are using LEDs or energy conservation motors are all be implemented through energy conservation systems, so that the demand that's given in this. Conclusion of the demand management system DSM reduces the need for new power plants and transmission lines, lower the energy costs for consumers and utilities, enhances the grid reliability and reduces the blackouts, supports the environmental goals by lowering greenhouse gas emissions. The second one is to reduce the peak demand response program of this one. What is demand response program? It's a tariff or program established to motivate the changes in the electric use by end-use customers in response to changes in the price of electricity over a time, or to give incentive payments designed to induce lower electricity use at times of high market prices or when grid reliability is jeopardized. The main difference between the DSM and demand response programs are DSMs are utility level programs and implemented by utility based controls, whereas demand response program can be done by both utility as well as consumer level separately or together to achieve a low peak load curve and reduce the electricity cost. In the demand response programs established to motivate the changes in the electric use by the customers in response to changes in the price of electricity over a period of time. What it says means, if you tell me that the energy price is very high at this period of time, if I am bit sensitive, then certainly I will avoid consuming energy at that period unless I have some critical needs. That means when the prices are increased during peak hours period, the demand will be reduced by the consumers. Consumers can involve in shifting the loads through load shifting, load valley fills, or conservation, so that the consumers can reduce their electricity bill also. Demand response program, you see that black diagrams in which independent system operator determines the preferred demand value and time duration that is offered. Aggregator receives the load data from ISO. Aggregators, depending upon their availability, accounting the number of interested consumers agree with the proposed DR. The aggregator optimizes the demand. Successful implementation of the DR program is possible users participates into style. Demand response program does not ensure same amount of benefit for some may be incentives, whereas some can receive penalties. The employment secure communication system. The last is electrical grid is tariff implications. The smart grid tariff implications refers to how the introduction of smart grid technologies like smart meters, real-time data systems, and advanced demand management will affect the electricity pricing and the way consumers are billed. Here is some detailed breakdown of the key implications. First is dynamic and time-based pricing. Time of use tariffs. Different rates for peak, off-peak, and mid-peak hours encourage the consumers to shift their consumption to cheaper periods. Real-time pricing. Prices change hourly or even 50 minutes intervals based on the market conditions. Critical peak pricing. Extra charges during critical demand periods to discourage heavy usage. Impact on the dynamic and time-based pricing is consumers who adjust usage can save money. Utilities can reduce peak load and avoid expensive generations. The second one is demand response incentives. Smart grids enables automatic demand response where appliances or industrial loads to reduce or periods. Tariff may include rebate, improves reliability, and delays cost creation of distributed energy resources. Tariffs can support net metering or feed-in tariffs. Smart meters measures bidirectional flow, enabling accurate for exported energy. Impact is redesigned to ensure fairness, cost reflectivity, and transparency. Smart grid actual consumption of generation, transmission, and distribution. It will promote the efficient energy use but may initially increase big loads. Equity and consumer protection. Some vulnerable groups, that is low income group or elderly group, may struggle to shift loads. So that government regulators often introduce tiered tariffs and introduce subsidies or opt-out programs to protect such consumers. Policy and regulation must balance cost recovery with social equity. Utility revenue models. These may face revenue restrictions. Tariff may include fixed charges, capacity charges, or grid access fees to recover infrastructure costs. Smart grids leads to more flexible data-driven tariffs and a reward efficient design to ensure fairness, protect vulnerable consumers, and maintain. Summary: it is an emerging technology to provide next-generation power grid and is promoted by many governments as a way of addressing energy independence and global warming and energy reliance issues. Sir, okay, sir. Thank you. To this, I conclude this session. Thank you for listening my class.
Thank you, sir. Good evening to everyone. Thank you so much, Sridhar, sir. Good evening to everyone.
Thank you, madam. Thank you for giving me the opportunity.
Organizing team of Sri Chandrasekharendra Saraswati Vishwa Mahavidyalaya. I take this opportunity to extend our heartfelt thanks to Sri K.R. Sridhar, Assistant Executive Engineer of TNPDCL, Ranipet, for delivering such an insightful and inspiring session today. Sir, with 27 years of experience in TNEB and your specialized work in the power transformer repair way, your knowledge and real-time experiences have given us valuable learning and a deeper understanding of the practical aspects of the power sector. I would also like to thank our management, faculty members, and participants for making this session meaningful with your active involvement. Thank you all. Thank you, sir. Let's
Thank you,
start
madam.
go
Thank you.
for a next session.